Hello, I'm Mr. Muskeluk, your AP Chemistry teacher at ChemAdvantage.
Well, here we have a AP Chemistry particulate drawing, and you'll find them on all the AP exams, and this is pretty much what they look like. Let's look at this one and see if we can pick up some tips on how to think about these drawings. We have a beaker X and a beaker Y and a beaker Z here. Okay, we've got pluses and minuses that are going to represent something. In this case, they've got to be ions in solution. X and Y each contain 1 liter of solution. So we've got 1 liter here, 1 liter here. A student combines the solutions by pouring them into a larger, previously empty beaker Z, that's what we have here, and observes the formation of a white precipitate. In answering the following questions, you may assume the volumes are additive. So let's look at those last two statements. A white precipitate, okay, this is a solid. The ions have snapped together, and we can see these pluses and these minuses have come together to make a insoluble precipitate. Also, if we have 1 liter and 1 liter, and they say the volumes are additive, we can presume this is now 2 liters. Okay, so we can sort of see what's happening here. Let's look at the questions. Let's go through all of these. Using your knowledge of ions and solubility. So we have to know about ions and solubility. Identify each substance in the diagram. Okay, we've got a plus here. Okay, that means it's a cation, positive ion with a +1 charge. Well, what are our choices? Let's look at them. Sodium ion has a +1 charge, so does the silver. The magnesium has a +2, so we can ignore that. Ammonium is a polyatomic ion, so we'd have not just one little particle there. Chloride's negative, nitrate's negative, sulfite's negative. So the only two choices that we have are sodium and silver. Now we notice in this reaction that the plus forms a precipitate. Now, one of the rules in AP chemistry is that all sodium compounds are soluble. So it wouldn't form a precipitate, so we've only got one choice. That's the silver ion, because it is the one with a +1 charge. It's a cation, and it has a ability to form a precipitate. So we'll put in silver ion. Now this next one we can see is a negative ion, and a negative anion, and it has a -1 charge and has 3 parts to it, a center and 3 other things. So it's got 3 atoms in it. Well, that eliminates the sodium and silver and magnesium and chloride. The ammonium is NH4, so that's got 5 particles. The nitrate has 3, an NO3, and has a negative charge. So without doubt, this is going to be the nitrate ion. Another thing that is good about this is you notice that the nitrate isn't involved in the precipitate. That's one of the other rules in the AP solubility rules, is that nitrates never form a precipitate, and so they'd never be here in a solid. Doing well. Now, we've got to identify these negatives. Well, there are quite a few substances with negative ions, with a -1 charge, anions, and sodium and silver, forget it. Magnesium's positive, ammonium's positive. Chloride has a -1. This isn't a nitrate because it's only 1 particle, and a sulfite is a -2. You've got to know your polyatomic ions. And the sulfite is like the oxides, a -2, so we can identify this as chloride. Now we've got a +2. Well, we didn't have that many choices that were a +2. Here we had magnesium. That's the only one. Now I'll pick that, and we see that the +2 is floating around, not doing anything. Okay, it's a spectator. Now what do we have here? We've got a +1 and a -1. We've identified them. That's going to be silver and chloride. That's an easy one. Well, once you figure all this out, it is, but this is a solid. And it's the silver. Sodium could never be it, and we've already identified the silver it being there. So this is the only choice that's going to make any sense at all. And it's a notorious solid. AgCl, Ag +1, Cl -1 is a favorite precipitate of chemists. A white powder that if you put it in sunlight will break down into silver and chlorine, and you'll get some powdered silver if you leave it in the sun. Now I'm looking here. I see my nitrates are floating around. My magnesium +2 is floating around. And the silver chlorides have clumped together. Let's keep on going. There's a few more questions here. If the solution had a solute concentration of 2, that's our here. This is our beaker X. It has a concentration of 2. What is the concentration of the solute in beaker Y? Well, okay, we've got to do some counting. Let's see. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I think. There are 10 particles of silver, and I bet you there are 10 of nitrate here. If you want, you can count them. Now, here, it looks like it's a little bit less packed, so we might think it's a little bit less concentrated. Now, we've got magnesiums here, and we've got chlorides. Well, we know the formula would be MgCl2. So we would have to divide these chlorides by half. Let's see how many of these magnesiums we have. 1, 2, 3, 4, 5. Half as many. So that concentration is going to be, what's our choice? 1 molar. Half the concentration, because we have half as many magnesium ions. Now the chloride is double that, but they didn't ask about the chloride. They said, what's the solute? And we consider the solute to be magnesium chloride. If solution X had a solute concentration of 2 molar, okay, here's X, 2 molar. What is the concentration of this nitrate ion in beaker Z after X and Y are mixed? Well, we know the volume is double. And here we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in a 2 molar solution with, because that's what they said this was, it was 2 molar. And now we have the same 10 spectator ions in 2 liters. That makes it 1 molar. So we've got ourselves this completely figured out. We didn't even need those hints. Just be logical in dealing with these particle diagrams. You might have to do a little bit of pluses and minuses, but if you've got your chemistry ideas figured out and your knowledge, you'll be able to deduce whatever these particle questions are. There's AP Chem particle diagrams.